Okay, so I actually have this full screen, so I can't see any of you, just FYI. So if you need to break in, you should break in and say something. Anyway, it is April 27th. I am Sarah Graf-Henny Palermo, and this is the tale of the pipeline graph. So this is a story about changing a graph that looked like this. Please notice, by the way, these very exciting lines and arrows here. It's very important to the story. Changing this graph to look like this graph. It's a very lovely new graph. And you might be wondering, why is this interesting, right? Why should you care? And I think it's not just that the feature itself is interesting, although it is, and we'll talk about SVGs and fun stuff, but also I think we'll be seeing a lot more projects like this, namely projects where we're looking at how we want to stabilize and extend older features in our code base, as well as working with an eye for stability and safer rollouts when we're sending them out to people. Finally, I ran into some fun code problems that I just wanted to share, and that's what will be included in this. This talk is pretty much the tip of the iceberg for everything that I'm chatting about. So you can put your questions in the agenda. If you have deeper questions that are not addressed in this, please, by all means, like set up another call with me and I will go into it in detail. I'm really excited about it, but I wanted to sort of go for breadth. So we're going to have a rambling talk that'll cover the background of the project, its goals, the story of the project itself. This is like the main part, has all the code in it. And then we'll talk about sort of where we are now and what we expect in the future. But first, I wanted to share some stats. This project covers 50 plus MRs. 10 plus teammates were involved. I wanted to give extra shout outs to Laura, Frederic, Marius, Jose, and Andrew, who helped either doing backend code, helping me figure things out, doing all of the maintaining and reviewing. So thank you to all of these people. It also involves tens of thousands of data points now in Sentry and Prometheus, and in 12, 16, 5, 6 months, really depends on where you start counting. So if we want to start counting at 16 months, we can look at the background, which is in 12.2, directed acyclic graphs were introduced. The feature flag was removed in 12.10. Essentially, directed DAGs make it possible for jobs and pipelines to execute based just on which jobs they explicitly need. That's why we have this cool needs keyword. And that's neat, but it causes a problem or a challenge when you look at our graph. This is a graph that's probably very familiar to you. And we can see now that it's like stage by stage, but some jobs have already executed, some jobs haven't. What's the order? What's the rule? We don't even know, man. And so we started looking at different ways to make this. This is actually a slide from Dimitri from about a year ago now, looking at different ways that the graph could look. It has one of my favorite comments ever in a slide deck. We have some problems. It was a big challenge. We narrowed it down and focused on creating this separate graph that shows the relationships between jobs, but not any statuses or actions. And it was basically the most pared down way to start to answer the question of like, how do we calculate and show these relationships in a useful way? And can we do it without messing with the main pipeline graph? So we made this, we rolled it out. Users came back to us and basically said, no, it needs to be on the main pipeline graph. All I want to see is this on the main pipeline graph. Right, so it's like, okay, great. You want the thing that's hard, but maybe this was also an opportunity, right? The graph was cramping our style. It was a little creaky. We couldn't show links beyond the next column. They were CSS borders that could only go there. The graph was very brittle in terms of layout. I called your attention to those lines not lining up. Basically, anytime we wanted to add a feature to the graph, it was like, no, we can't do it. We're going to break everything. Please, let's not. And finally, the endpoint limited the number of upstream and downstream generations that could be shown on a graph, but that was sort of inherent to the way the REST endpoint was being calculated. So there were a lot of things we wanted to fix. And GraphQL was on the horizon for us. And that's partially because we wanted to keep the section in line with evolving approaches. We were using the mediator pattern, which is our like pre-UX pattern. It was a little old, so just to keep up to date. We also wanted to allow front-end engineers to better self-serve. This is really vital on Verify. I think it's probably vital on all teams, but Verify backend engineers, if you've been seeing the rapid actions and the CI scaling work, those are often the same engineers that we're going to ask to help support product work with backend changes. And so to the extent that our front-end engineers can self-serve, it was a really big win for us. It allows non-contiguous apps to share caches. Because pipelines pages are old, we still have a mix of XAML and Vue, but using GraphQL means you can share the default client, and so it can share caches, which was a bonus to us. And we'd already done a small test on GraphQL. That DAG graph I showed you before was the first thing we moved to use GraphQL. We chose that because it was new and small, but luckily it covered a bunch of the same data that was in the pipeline graph, so we were like well on our way. So the project goals were then to replace the REST endpoint with GraphQL resolvers, to show the jobs by layer or job dependency. A quick note here, I never say execution order when we're talking about this view, because technically something that depends on 4 fast jobs will execute before something that depends on 1 slow one. And I found that our users have very idiosyncratic ideas of how things work. So we should only say the words that are very, very true about them. And so it's not exactly execution order. We wanted to show the links between jobs across multiple columns. And we wanted to do all of this in a way that a version of the graph could also live in the pipeline editor section. This is the pipeline editor section. And though the data shown in the jobs is different, right now it's names, it might grow into other things, it's conceptually important for them to be the same graph and stay connected. So that was a primary goal as well. Okay, how did we do all of this? Let me have some water real fast. So planning the project. This is a big project, right? How did we conceive it? How did we plan it? How did we get away with doing it? It was essentially sprouted in a space where there weren't a ton of new front-end features, and there was some turnover going on our team. So maybe there was a lot of engineer ideas and not the most supervision. And I know it sounds naughty to say, oh, we started this when no one was looking and then we just went. But I think it's important to think about that so that we can start thinking about how we make these kinds of projects less of a surprise or a skunkworks approach, because the outcome is super worthwhile. And I think that as the company continues to mature, we're going to want to continue refreshing parts of the UI in bigger ways. And we should keep that in mind. So, you know, we broke it up. I wanted to still have a spirit of iteration. So we did a spike, we replaced the graph, we added the higher order components, we updated the specs, we added the links. There were surprises everywhere, but I'll talk about them there. And then we did the rollout. So in terms of communicating the project, it was also a little bit different and a little bit of a challenge. The spike was, as you expect, one issue. We listed the questions we were going to answer. I wanted to be really responsible and say, this might take some time, but like we're not going into a hole and just coming out with something at the very end. Then we broke that into an initial plan that I expected to take 3 milestones. You can see down there, it says 13.8. It's 13.12, and both flags are now just defaulted on to give you an idea of how this plan sort of grew as we worked. But we tracked that in one issue where I could mark where things were resolved and add new things as we sort of discovered problems. And I felt like this worked much better than that like 1 issue, 1 milestone thing to keep everything in one place so that conversations didn't spiral. It also meant we could leverage GitLab and use the related merge requests feature. I use this to look up old merge requests all the time for this project. And then to do sort of smaller communication, I used a Slack channel for the feature. We had done this with the DAG, and in that case, there was a lot more back and forth. This one was sort of more me talking to the world, but I really liked using it. I felt like I could be more informal and keep everyone up to date. I did get feedback that some people felt like it was harder because it wasn't in issues. So as you're doing projects like this, it's definitely an approach worth considering, but one with pros and cons. Okay. That's all the organizational stuff. Now let's talk about the code. The first step of the project was a month-long spike. I had a theory that all of this would work, so I just wanted to test it out with non-production level code. This is my favorite MR summary I think I've ever written, never merge me. So we did a non-production level change. It gave me something to pair on with Fred for our theories about how to link the 2 graphs. And though, as I worked through it, I was able to work with our backend engineer with Laura to create the GraphQL endpoints we would need for the production levels. So we did a spike, but we did combine it with getting ready to go into the next phase. And I think that was really successful. And Laura mentioned, we used client resolvers to do this, which I think is a pattern we've been seeing people use more and more. And Laura mentioned, it wasn't just that this was nice because I could identify the shape of the data and share it with her, but she loved being able to pull the branch down so that she could actually test her code against the front end. So that was really successful as we moved into the production code. So we needed to replace it in place, right? Unlike other iteration work, you can't take away a whole graph and then slowly give users a graph back. That's not possible. So unsurprisingly, we decided to use feature flags so the MRs could stay small and we could pair the feature changes with their specs. We could have worked on a feature branch, but because it was going to take a while, we wanted to just work against main, against master. And that also made the GraphQL changes available to everyone as we worked so that we were still getting feature work done while we were doing this refactor. We paired the feature flags with async loading though, because this was going to take a while. We didn't want users loading code that we knew didn't work, right? And we did some performance testing on this. This is kind of what it looks like, and it was successful. It was a little bit faster and we weren't giving people code they didn't need. But we weren't going to duplicate everything, right? At some point we were going to duplicate components. At some point we needed to share. And the primary drivers of the components we chose to duplicate were cases where we were doing a lot of the data work, right? Which was cases where the components were doing a lot of data work, making the API calls, formatting the data. Those should definitely just be separate. But also cases where changing structures were breaking the CSS. The CSS used to create the links and the graph, as we mentioned before, was pretty brittle and it was very nested. So like something as small, right, as like changing a div or moving one thing would break the entire graph. And so that also drove, there was at least one level of component that I tried to share across both implementations and it couldn't handle it because of the CSS. This is me tearing my hair out using outline to find where the CSS was highlighting different things to make sure we could understand what was up. So in the end, we use this diamond pattern, right, where you have the shared parent and that's where we're doing the async loading to decide which should load. Then we have the duplicated elements, and then we have the shared children where it's simple enough and display enough that we only need to change a little bit. Something nice here, of course, is that by making legacy files, we also made legacy unit test files. So we didn't need to adapt the tests as well. I think that would have taken so much more time. In this way, we just have very clear files that we can delete when we're done, and we know that it's all done. And by not trying to worry about sharing the GraphQL with the REST calls in those components, it meant that we could focus on sharing our GraphQL with the new components that needed to share the like unwrapping and parsing data, which is the pipeline graph and the DAG, right? Like by not trying to make it do double duty, we could make sure it was in line with its other components and not sort of infecting them with the restructure. In that third case, where we have GraphQL and REST in the same component, we dealt with it in two different ways. The first is actually relying on aliases in GraphQL queries themselves. So GraphQL type names sometimes need to be different than the REST name. Something was called status. It is a detailed status in GraphQL because it can't have the type name of status. Here, we can just rename it. Every component wants to call it status rather than like renaming it everywhere, right? We can rely on GraphQL. In cases where it was a little more complicated, we used an accessors pattern. In this case, right, it's just an object where you can look up the accessor for a given attribute in REST or GraphQL. And then in the component itself, like the job item, we use the access value to look it up. It's nice because it means that we can use inject to inject GraphQL, but default to REST so that anything else in the code base that is still relying on this job item doesn't have to know what we're doing, and it can be fine. And in cases where that's not going to happen and we're going to delete it when we delete the legacy code, it gives us basically a table of contents of all the places to go delete things instead of sort of combing through the code searching for or again. So I thought that was a big win. And one last data consumption pattern that helped us cut scope, which is funny to say because this is really big, is the way the action items were implemented. And this is before we started this project, but these little items here that let you do things on your jobs, those are actually entirely self-contained REST components that just emit an event when they're done. And Philippa notes, I love it. She wrote this comment about how this should not be done, but it's being done because it makes more sense. And so I want to salute her and encourage you all to break the rules when it makes more sense, because it totally saved our butts here. It would have been, you know, another week or two's worth of work to try to move all of these to mutations at the same time. So then once the graph was replaced and nothing was different, except that the links are gone and we could show a view without the links. We added the higher order components. And again, the higher order component is how we keep this graph and our other graph in sync. There are 3 of them. The first 2 are just about CSS, the main graph wrapper and the linked graph wrapper. And this is sort of what you do with utility CSS instead of old style CSS to keep them in line, right? The higher order component just says these things look the same, but instead of being classes that you need to grep for to see where they're in place or having them sort of crash into each other, you can just put your utility classes there and be like, great, they're shared. The links layer is the third and the meatiest. It conditionally renders the links in the SVGs and calculates them and all sorts of things, and then shows the graph. It also takes care of performance, reporting performance to Prometheus, which I will talk about later. But this is another pattern, right, that we're starting to standardize on. Michael Luno wrote one of these for the top level, where you can sort of only conditionally render something when you have it, and the wrapper component is just checking your conditions. And then it draws the links, which are so awesome. And the real innovation for this that drove most of this project is that rather than having to calculate links in a way that means we know where the jobs are, first we just draw the jobs and then we calculate the links afterwards. So we really draw all of these job pills and then we read their locations out of the DOM and use that to generate our links. Yay, no more brittle links. We improved the approach that I took in D3 DAG in this version, and that is that in the DAG, we let D3 do most of the drawing. My theory there was like, let's not set a bunch of view getters and setters for like data that's not important to view. But basically, as soon as something touches Apollo, it's in view and view is going to know about it and deal with its reactivity. And so once that's the case, the second version, which is what we're doing in the graph, where we're using the declarativeness of view to work for us, was like a much better option. In general, this pattern of using the links layer, a higher order component for it, has been moderately successful. I think I'm fairly happy with it. The one thing I'm not happy with is the parent component still has to do a lot to deal with sort of graying out the jobs that aren't involved, etc. I have some questions in general too about whether we need such a complex UI to show this. People like it, but it might be possible to show information in another way. So that's something we're still keeping our eye on for iteration. Another big challenge with that is actually that this is a recursive component. So the pipeline graph has a linked pipelines column, but a linked pipelines column contains a pipeline graph. I was thrilled when I found out you can do this in Vue. It is useful when you need to have child components that can be of an indefinite length. But it means that drawing the SVGs is a little complicated. You need to make sure that they're next to each other and not inside one another. And you can't make certain guarantees about the data, right? You can have jobs with the same names, but jobs don't have IDs. Job groups don't have IDs in our data. So you end up doing funny things to make sure you're not drawing links in the wrong place. The other sort of downside of this is that in Vue, you cannot guarantee when a component mounts that its child components have also mounted in the DOM, right? If you wait for the mounted lifecycle hook, it might not be loaded yet. And so we have that problem when drawing the SVG that we need those jobs to be rendered before we can draw the links layer. So basically in the child component, we emit an event being like, yes, I'm actually done. I checked with some Vue folks because I was a little worried. I was like, this feels like a bad way to do this. But it's not, that's just sort of what you get in time guarantees. So then the last stage was updating RSpec specs. So when we started, we just defaulted the feature flags in RSpec to off because we knew we were going to be sort of working incrementally and that no one was going to be able to see it. So rather than keeping it in sync the whole time or something, we just said, RSpec, don't worry, we'll come back at the end. I think that was successful. A weird note, RSpec defaults to on, just defaults flags to off. So if you're working across those two borders, definitely keep that in mind. But once we went through and found the few blocks that needed to be duplicated to support legacy and new, it's great because again, they have the flag off. So it's really easy to find which ones that we need to delete. I also learned something fun from Laura, which is if you don't know why your RSpec is failing, don't run it headless, but like actually let the browser open and look in the network tab. That is how we found a secret like week-long bug. All right, yay, we made things. That was super cool. And now it's time to do the new layout, the whole reason we did this. And this was like the test of my idea. Like if we did all this work and made it like the DAG, then making the new layout should be simple. And was it? Yes, it was. It was this many lines. It took me 15 minutes. I wrote this many lines of code. We've done all the work that led up to it. And it was perfect, right? Done. Yes, except my enemy, polling. We poll for the pipeline graph because you want to know if your job is succeeding. We poll every 10 seconds by default. And polling complicates this quite a bit. I would say Apollo's heel in this case is fragments and normalization. We get the data we want in one format, right, by stages. And then we need the things that are updating are really inside these statuses. And Apollo, right, we get it, and then we calculate the new layout, and that's a little expensive, so we don't want to calculate it every 10 seconds when we get new data. But Apollo can make it very difficult, especially for something like groups that don't have IDs, to get the data out of the cache. Even though Apollo has normalized it for us, that should be good, but it's a bit of a challenge. In Apollo 3, cache.identify, you'll be able to pass it a fragment and it'll be able to find it for you. And that will be great. But we don't use Apollo 3 right now. We use Apollo 2. So I ended up creating a sort of homegrown version where we calculate the layers and create a lookup table. And then we use our lookup table so that we're not recalculating the layers. If you want to see what that is in detail, I will post these and you can look at those links. But essentially, that's what we chose to do. I think it was right for now, but I'm looking forward to being able to leverage the library instead of our own solution. The other really fun part of the segment was the implementation of these loading links, right, which seem really simple. You click it, it loads while it does the work because there might be a big graph, and then you don't freeze up the UI. If you look at the code behind that, you actually have to use set timeout to make this work the way that you would expect to make it work in Vue. And you can't use next tick. Why is that? This is a graph that may be familiar to many people. Essentially, this is the way JavaScript works in your browser. You have a call stack, it does a bunch of events. There's a render loop and a callback queue. And what we need is to start the loader rendering in the render loop and then do the work. But Vue next tick comes at the end of the call stack before you render, which is often what you want, just not in this case. So if you're trying to do these kinds of work, you can use set timeout, which will put your work into the callback queue, which is where you want it. That was a bit of a surprise. There were a couple other surprises that are worth keeping in mind. The first one is dark mode. This shouldn't be a surprise, but it is sometimes. I think it's still sort of a second citizen. So if you are doing UI stuff, make sure you think about dark mode. Simon is great. He just did like a sync call with me to look at everything and fix it really fast. So I highly recommend doing that. The other surprise, the biggest surprise, was polling again. This was like the most destabilizing shock in this whole project. It probably delayed us by a milestone or a milestone and a half. And so I was like, polling, GraphQL has polling. That's great. We can delete our homegrown version. We'll not delete it because other people use it, but we can cease to use our homegrown polling. And instead, we can use the Vue Apollo GraphQL client. Like, yay, that'll be great. But it's basically naive polling. And we have sort of big, robust GitLab level polling so that we don't accidentally DDoS ourselves. So we took out some time to look at the solutions, and it turned out that the E-tag that we use with REST now, we could still do it. So that's great. So basically now we poll Rails, and Rails asks Redis if anything has changed comparing the E-tags, and it can decide whether or not to do work. There's a whole page about this in our handbook as well, but it's very exciting and it saves us re-renders. And thanks to the work of Jagorsh and Marius, we were able to like get this done fairly quickly, considering how late in the project we were like, oh no, polling. But to do that, we had to use another GraphQL library. There's a link here to like all of our GraphQL polling docs, but you basically have to say use get, and then we use a different link library because the batch library won't support get, but you need get for E-tags. I have a lot of opinions about this, but basically this is our solution for now. eventually we will have subscriptions and none of this will be your problem. But if you are polling, you're not going to be batching. And if that matters, it's worth knowing that that trade-off is going to be there. I found a fun bug too. If you're doing this, you might find that polling is working on your local dev machine, but not on production. And that's because Rails is basically more forgiving than HA proxy and Nginx. Heinrich helped me figure this out. I've just saved it here so that you all know it could happen to you. Finally, the biggest surprise was that we had to rethink the UI at the last minute. It ended up that we took the links out entirely on the stage view. And users were really surprised and were like, oh my gosh, my links are gone. Is my graph broken? And we were like, they don't mean anything. Those links never meant anything. Like, why are you surprised that they're gone? They didn't do anything. But people thought they did and didn't realize they were fancy borders. And I think Sam is like still writing a post about that. So you can talk to him about it too. But it was a really big surprise. And then that fun bug I mentioned to you last time, the dropdown. So I ran into a case where if you clicked on something and then you hovered over a job, Popper would no longer make the dropdown go away. I was very confused about this. It turns out that adding the class when Vue was re-rendering the DOM nodes made Popper lose track of that DOM node for whatever reason, whatever reference it is keeping to that node, it does not work. So now we just have a wrapper class. When we replace this with a new dropdown, it might not be as much of a problem, but you know, if that happens to you, it might be adding classes. All right, so we wrote all the code and we had to write it out. This is probably roll it out. This is like my favorite section, maybe. Put it at the end, but I like it. Because the code I've shown you today was rolled out in two pieces. The new layout, which was the second rollout, that went to 100% this morning. I'm very excited. It was fairly straightforward. But before that was rolling out the revised graph, which was utterly and absolutely terrifying. We had on Verify some higher profile reversions at the end of 2020, which was no one's fault. The code's very complex, but we wanted to sort of come up with a plan that like maybe not do that again if we could avoid it, because it was, you know, it would be nice not to. But we didn't have a metric about whether something worked that was not complaints. And whether complaints should count as a real metric, it's definitely a lagging indicator. So we wanted to figure out how do we do this a bit more safely. So first we did like a cautious plan for the rollout, right? Standard GitLab rollout UI, the project itself, then to .com. But we started with what I was calling the private beta. We asked users to, people at GitLab, since the pipeline is used often enough at GitLab, we could just ask people here, which was really helpful. Like if they could stand some broken stuff, if they would mind using it first. And we found like a solid set of UI bugs. And I really appreciated that. So I highly recommend it if you're doing a rollout that you're a little nervous of, or you really want to go right, just taking the time to do a private group of users was cool. More importantly, we started looking at a rough kind of observability, a way to know things about our running app, right? A set of real-time indicators so we could know what working looked like and what wrong looked like. And there were 3 levers we could pull here for these metrics, and none was perfect. Snowplow is set up to work with the front end really well, but it's not real time, so you can't flip a flag and be like, okay, Snowplow, tell me if everything's broken. Prometheus is real time, but it's not really optimized to work with the front end. You need a back end endpoint. And so using that consistently could cause performance issues because now you're adding a whole new set of calls to the back end. Sentry is set up to work with UI and real time, so that sounds really good. But it doesn't have source maps. It's very error focused. So I think it's harder to use Sentry for, you know, like if you just want to find out about something. And in our case, it was not actually on. We spent about 2 weeks, and by we, I mostly mean Jose, trying to find out why Sentry wasn't working. So this is a little note. If you turn something off to investigate it, please have a plan to turn it back on because people might be surprised. But we went ahead and charged forward with Sentry. We leveraged the ability to provide component names, right, to make up for the source map so that we could at least have some idea of where the error was occurring. We added calls to Sentry, you know, where we expected errors in the Apollo error handler, stuff like that. But Vue also has this error captured hook that will be called when an error is captured, right? When just some error gets called. And this has been really helpful to help us find the errors that we didn't expect. likewise, we use a report failure pattern in PA and CI, which is just a way of centralizing, right? Getting an error, displaying that error at sort of the wrapper level component. It's not super complex, but the nice part about having that pattern is that it meant there was a really obvious place, again, to add our sentry call. So it was nice. It made us feel like we made good architectural decisions when it's like, oh, we can like slot this in. And it worked. It worked almost too well, I want to say. We discovered a bug because someone clicked on like a 3-year-old graph once and it showed up in Sentry. Old graphs might not have IIDs, but the GraphQL interface assumes that all graphs will have IIDs. You cannot get a pipeline data. Well, pipelines will have IIDs. Like you can't get a pipeline without an IID if you're using a new endpoint. So there's probably important lessons about interface assumptions here, but you know, Sentry was really helpful. We found really crazy bugs. We also found another one. This job is undefined. It took a really long time for us to hunt it down. We rolled out the new graph and most things were good, but I was getting us think like this job is undefined. And I'm like, why is that happening? And we click links and it only happened on private repos, right? So we couldn't see it, we couldn't observe it in the wild. We just knew that it happened. And the Sentry feedback cycle is a little bit slow. That's one of the cons, right? You have a question, you can add a log to Sentry to like put the data you need in there, wait a day plus to deploy, and then see what happens. And you can make it a little bit better by adding some feature flags and a couple of hypotheses when you roll it out. So you can test a few things, but you still basically have that day-long cycle to see what happened. We even tried reaching out to users. So instead of just asking the code to tell us what happened, we reached out to users. They didn't respond. In the end, it's coming through the backend empty, handed it off to some backend engineers. I think it's a permissions problem where someone can see a pipeline, but none of the jobs in it, which is very strange. Was it worth it to spend all this time to find this tiny bug that nobody complained about? I don't know. I think that is an important question to ask when working on Sentry is sort of, if we can do this, then what are our guidelines? What do we do with all of this power that we have? But it was very successful too. I rolled out something earlier this week. Something was undefined. I was able to see it on Sentry, identify the problem, and merge the fix in like an hour. And again, it's not something that happens all the time. So we might have gone for quite a while without knowing we had this edge case bug. So it worked. I was very happy. Observability is not just about errors, as I mentioned before, right, when I was talking about Sentry, but it's also about performance. One concern about moving these links from CSS to actively calculated SVG ones is that the performance of iterating node over nodes, it's unclear, especially because we don't really know what size graphs we have. So without the data, we used a tripwire, right, which is like what you'll see on the issues page, where basically like, if you have too big of data, we can't show you the links to start off with. Fred has this great YAML generator. When you work on CI, you need CI YAMLs a lot. So he basically tested graphs for me and kept making them bigger until we found out what was too big and set the tripwire. But more, I wanted to be able to use observability to answer like 3 important questions. How long did it take to draw those links? How many links were we drawing? And what's the job link ratio? Because we make assumptions about how our pipeline graph works that are not necessarily true or accurate. You know, all of our examples have up to 100 jobs, say, some links, but then we'll hear things from clients like, some people have 300 downstream pipelines. Some people are using matrix jobs. And so you can have like 900 jobs and job groups, and it can get really big. And we have not necessarily been thinking about that lately because we don't know. But we wanted to know those things. And so we did set up a backend endpoint to forward these 3 performance metrics to Prometheus, right? We were able to use the performance work that Dennis did that works in like the performance bar on dev, but sort of have it run in production and send that information to us so that we can know more. What we know yet, I don't know, because this is pretty new and we haven't really gone through and come up with something actionable, but it's the kind of work we can look for with front-end observability if we keep growing in this direction. These are the kinds of questions you can answer about your work, which I think would be really important. Finally, I have been a Frontend Fixtures skeptic for a very long time, but this project changed my mind about it entirely. At least working with GraphQL, I think using front-end fixtures for anything that's grown slightly large is 100% worth it. Mock data can be really verbose with GraphQL mock resolvers because you need to add type name to everything, which can get really big. And it sort of helps cover an integration point where we've run into cases where people have changed GraphQL types on the back end and not known what that's going to change on the front end. And I think that, you know, more than worrying about it in Capybara, making a certain level of integration test in our jest tests by using the fixtures is like a really helpful place to just double check that things aren't breaking. So I've totally changed my mind on this. And that's basically where we are today. That is our whole adventure. Still to come, right? The next things that are going to happen is deleting the old code. I can't wait. There's going to be like a negative 2500 MR. It'll be glorious. Visual testing. So this was something I really wanted to get to make our rollout safe, and I just didn't have the time. It's kind of hard to figure out how to render all the visual variations that you need in a visual test. I believe we've brought or are bringing Storybook to the main GitLab repo for like view shared components. And I would be interested in looking at what it would look like to create test cases using that. So, right, the pipeline graph can have so many different setups, modes, etc. It's impossible to test them all manually. And so I think this is a really important case to look at how visual testing can help us. Deleting tests. I'm excited to delete tests. There's 1,700 lines Capybara tests for the pipeline graph, which is like 1,500 lines too many tests. So, you know, looking at what we're unit testing, especially if we're using fixtures, looking at what visual testing can pick up to bring down those tests, I think will be great. There will be more performance enhancements to come on the links. The links are okay performance, but there's a lot we could do to make it better. More fun ways to understand job dependencies. I'm excited to see like where this goes in terms of product. And then I am waiting with bated breath for Apollo 3 and subscriptions that will take out maybe 60% of the complexity that is still in our code. I have a lot of different takeaways I'm going to run through really fast that are mostly things I said, but they're here if people want to look at them later. It's worth thinking about how to integrate this type of maintenance into our project planning. Right, I did this and it worked out well, but we should think about how to plan for it. Nested CSS is a trap. I like nested CSS just fine for small projects, but for something the size of GitLab, it was really hard to change. And we kind of had to delete a bunch of things just to make it possible because untangling it was really difficult. Client directives are great and make everyone happy. Using GraphQL made it a lot easier to keep our front ends in different apps in sync and let them share the data, which is the thing they really share. Use async loading to keep from loading code you don't need if you're doing something bigger. If you're thinking about Vue versus D3, just use Vue. You're not going to save the performance you think you might. Naming is hard. Oh, I meant to say, naming is hard. This is a whole different story. I want to hear questions, so I'm not even going to talk about this now. Ask me some other day. Removing things can make things easier, but also confuse people. Like those links didn't even do anything, man. I should have written more of an architecture plan, which we have done since for the pipeline editor. And by we, I mean Fred wrote a really good plan. And I was like, yes, Fred, that's a really good plan. Good job. This might have helped us catch the polling problem sooner, if not other edge cases. I think that was a big mistake. And we need more support for dark mode just generally, right? Like I feel like it's kind of a hobby for one engineer right now. And it sort of feels that way. And it would make our product better if we had a little more, I don't know, structural support for it. And finally, use fixtures. They're great. That is my takeaway. The bigger things I'm thinking about now is what would an ideal cadence of this kind of modernization look like? What's the right balance between homegrown code and library code? Did I make the right choice when I was like trying to convince Apollo 2 to work as hard? I'm going to write a lookup table. And finally, what should we do with Sentry and Sentry errors? What would general guidance for all of our other teams look like? This is my like secret plug here. It's not a secret plug, but we're working on getting an observability working group up and going for front-end observability, where we can collaborate with infrastructure and even product. And I think these are the kinds of questions we would be able to answer. And I would be excited about that because it's done a lot for us, but I think it could still do a lot more. Anyway, now it's time for questions you're thinking about. Thank you so much for listening to me speed through this today. I hope it was helpful.
That was great. Thanks, Sarah. I've got the first question. It's a nice, simple one. Can we get access to the slides? Can you link them for them? Because there's quite a few links in there that would be helpful.
I will put them up and give everyone access. I didn't want to do it beforehand because I didn't want you to know about my surprise curses slide. So, you know, I didn't want to ruin the surprise, but yeah, I'll put it up.
I've got the next question. First of all, thank you for that. That was overwhelmingly impressive. My imposter syndrome is at an all-time high, so well done. Congratulations to you and the rest of the Verify team. Really good, awesome stuff. And on to my question. You mentioned upstream, downstream generation. Fred has answered something about that being. Can you go into a bit more detail about what that is?
Yes. So I'm like, oh, do I have the pipeline even running so I could show you? But essentially, in a pipeline, you can have linked pipelines that your given CI YAML file triggers. You can have jobs that you trigger. And when you look at the graph, there are cute little links to your upstream and downstream jobs, and you can click them and open them up and see that pipeline all in place. But the way that it was working with the REST endpoint and the mediator is that there were N+1 concerns about looking it up. It was all one API call, and you could call it with expanded values, and then it would go in and expand those values. But there was a certain natural ceiling to that. The way we restructured it with GraphQL, instead of using the old mediator, now those linked graphs can make their own API calls. So it doesn't, so you can do it until there's so many jobs in the browser that it will break your browser. If you have enough downstream generations, you can continue to do that until it breaks the browser. So that was a big win for us.
Cool, that makes sense. And I think that's agrees with what Fred said, which is good. I think I understand it roughly. My next question is, did you find, so view documents that you can do a next tick call within the mounted hook, and that will guarantee that the entire view has rendered. I've never verified this myself, but did you find that that wasn't true?
I did find that that wasn't true, that calling it in the mounted next tick was not sufficient for multiple children, because this is the thing I've now realized I sort of skated over. Because we're using the higher order components and then passing it through the slot, the next tick wouldn't, like, technically the child is 3 children down or 2 children down, because it goes through the links layer and then maybe into another slot, and it couldn't guarantee that. So I asked Natalia, I went to my known view expert and was like, I did this, does this seem like I was like, is this bad or is this the right way? And she was like, no, it's fine. I was like, okay.
Cool, that makes sense, thank you. And my third and probably final question for today, can you go into a bit more detail about why you want to delete around 1,500 lines of Capybara specs? Do they really not provide any value? And or what pain are they causing you as well?
They cause pain because they need to be updated when they don't use data test IDs, they use classes. So they cause pain when you move things around because they're brittle. If your layout changes, it shouldn't break the tests, is a personal feeling that I have. And that is not the case for a lot of those. And yes, I think they're trying to cover interactions that we can cover elsewhere now, either in our unit tests. So things like, if I click an upstream or downstream, does it open? I think letting the unit test handle that makes more sense, and are probably a little bit faster. And I'm just anti-Capybara, so yeah, I want to take it all away.
Small follow-up, which ones will you keep, Capybara tests?
That is a good question. I don't know. The ones the set tells me we should keep. I haven't gone through all of them yet. So the ones, if it looks like what we're testing is that we want to test that the data is being rendered correctly, right? That where we're getting our data, it's being shown in the pipeline correctly, and we haven't covered that, let's say, by using fixtures or something, where it's more of a real integration test. Like anything that could be in a unit test to me should be in Jest and not in Capybara.
Great, thank you.
Oh, and that reminds me of another plug for things I like. If in Jest you're testing the rendered data instead of using shallow mount and testing props, then that's another reason you can delete that test out of Capybara, because then you're not just testing props, but you're testing that it's rendering the correct thing. So it's another reason to not use props if you can avoid it. I'm looking real fast to see if I have anything that shows the upstream and downstream, just so I can show people pictures, but I think my local's kind of out of place. Are there other questions? I don't have the agenda in front of me. I like made my screen blink.
There's one from Justin, but he's busy blowing up the chat by the looks of it.
It's already been answered. I just wanted a link to the SVG rendering, and Fred hooked me up. Thank you.
Ah, nice.
Awesome. Sweet. So the next question is on me. I was wondering, there were a couple of touch points when it came to polling combined with GraphQL. So was using GraphQL subscriptions to get the update from the server side ever an option, or what were the blockers or issues with that?
Oh, it just doesn't exist yet. So when it does exist, that is what we'll do. We don't have subscriptions at the level for pipelines that we need to like do it. But yeah, that's the goal. We found out the polling thing rather late in the project. I had like a panicked week of like DMing our staff backend engineers being like, please, like, I don't want this project to end in flames. What can we do? Please help. And they did. And so this was, yeah, the solution until then. I was 100% panicking.
Awesome. And that was the last question of the agenda.
Awesome.
Anybody
timing
else?
worked out.
Just want to say great work, Sarah and Fred and rest of team. I'm so glad the graph is much more easier to maintain now.
Thanks. Yes, I know you suffered a lot of the pain that helped us get to the place where we could replace it. Peyton did a lot of work before the new graph happened, where people, product UX would ask, oh, can't we just change this one tiny thing? Can't we just make this 2 pixels taller? What could possibly happen if we made it 2 pixels taller? And you're like, the world will end. That's the actual answer. If you make it 2 pixels taller, the world will end. And I know that's absurd. But you know, when I said we sort of snuck into doing this, the wall we had, or the like protection we had, was we could say, remember all those things we said no to before? I know this is going to take a long time, but then we can say yes. And that did help a bit. So Peyton's suffering helped us all. And yeah, I want to say thank you again to Fred, most of all. We've been working on these links together in partnership this whole time. I mean, big stuff, little stuff, me just texting him being like, does this make sense at all? He's been super helpful. Andrew maintained like 90% of this. Laura wrote all of our backend. She wrote all of our GraphQL resolvers and was really helpful. Jose is like the king of Sentry. He probably won't want me to say that, because then you'll start asking him Sentry questions. But yeah, definitely ask Jose Sentry questions. And it was really great. So thank you, everyone.
Cool. Thanks, Sarah. This has been great. Yeah, I guess we can wrap up here, and yeah, see you all on another call. Take care, everyone.